It's been several decades since people have hypothesized that marine animals could use their whiskers to detect flow features. Biologists at the University of Rostock discovered that even if harbor seals are blindfolded and they have earmuffs on, they can chase the exact path an object took several seconds earlier. The theory behind this is that animals could use their whiskers to feel the deflection information from their whiskers in the nerves in their cheek. So I began my work studying how to design a biologically inspired sensor like that the seal uses. In my experiments, I designed physical models of seal whiskers that are scaled up, and I test their vibration properties as they're moving down our towing tanks here at MIT. So I designed a setup that allows my whisker device to freely vibrate in response to any flows. This is done by mounting a plastic whisker model onto a flexure system with strain gauges. What I found was that the shape of the whisker is very important to all of this. Normally, when a cylinder moves through the water, it produces large, coherent vortices, or whirling masses of water, that exert a strong force on the object. This can be visualized by injecting dye into the flow while it moves through the water. So the shape of the whisker is wavy, and it has an elliptical cross-section, and it has some asymmetries in the waviness. This unique shape sheds small vortices at varying points along its length, therefore desynchronizing or negating their effect on each other and minimizing the vibration. The whisker shape allows it to move smoothly through the water. So I conducted a second set of experiments in which I test the whisker's response to an external vortex wake. In this experiment, I set a large circular cylinder upstream of my whisker. That large cylinder generates a vortex wake, similar to the type of pattern that a fish would leave as it's swimming. What the whisker does in this case is it vibrates significantly, an order of magnitude larger vibration in certain cases. The second feature that I discovered, which was very interesting, is that the frequency of vibration of the whisker in this case exactly matches the frequency of the generation of vortices from the upstream cylinder. This means the seal could potentially determine the size of the upstream object. So in my work, I elucidated a mechanism of detection that seals could use to detect vortex wakes. I can imagine underwater robots using these types of whisker sensors to conduct targeted sensing, being able to hone in on hydrothermal vents or follow schools of fish to collect biological information.